This is Precalculus Chapter 3.4, Build Quadratic Models from Verbal Descriptions. We're going to look at 3 word problems in this lesson. Let's get started. So number 4, we're going to be working on the maximizing revenue question. So the revenue is quantity multiplied by the price. And the price is given above. So we have x times negative 1/3 x plus 100. So the revenue, R of x, is equal to negative 1/3 x squared plus 100x. So now I'm going to keep this function, R of x. So letter B, what is the domain of the revenue? So you want to set the revenue equals to 0, and then 1/3 x squared plus 100x. So 0 equals 2, factor out the x. That's x multiplied by negative 1/3 x plus 100. So setting each factor equals to 0, you have x equals to 0 and negative 1/3 x plus 100 equals to 0. So if you solve for x is going to equal to 300. So your x is going to be in between 0 and 300. So the domain of the revenue is going to be 0 is less than or equal to x is less than or equal to 300. Or you can write it in the interval notation. You can write it with a bracket 0, 300. So if it's asking for the revenue if 100 units are sold, just go ahead and plug in 100 into the function. So you have negative 1/3 multiplied by 100 squared plus 100 times 100. So the revenue R of 100 is going to be negative 3,333.33 plus 10,000. And this is equal to $6,666.67. So for letter D, let's find out the quantity x that maximizes the revenue. So you want to use x equals to negative b over 2a. B value is positive 100, so negative 100 over 2 times the a value is negative 1/3, so put negative 1/3 here, and this is equal to 150. So for the second part of the letter D, you want to find out the revenue when we have the quantity equals 150. So insert the 150 into x. So that equals to negative 1/3 times 150 squared plus 100 times 150. And this is going to equal to 7,500. For letter E, what is the price should the company charge to maximize revenue? So earlier we know that in order to maximize the revenue, the quantity it has to be 150. So insert 150 into x into the equation for the price. You're going to get price equals to $50. For number A, we got 3,000 feet of fencing available to enclose a rectangular field. For letter A, we're going to have to express the area as a function of x. So you're going to put A of x, and we know that the area is length times width. So you're going to have to put x, this is your length, multiply the width, you want to use 1,500, subtract x. So A of x is going to equal to 1,500x minus x squared. Put in the standard form, this will be A of x is equal to negative x squared plus 1,500x. And let's go ahead and keep that function, A of x. So for the letter B, what value of x is the area largest? You want to use the negative b over 2a, and b value is positive 1,500. So you put negative 1,500 over 2a value is negative 1, so times negative 1. And that's going to equal to positive 750. So if the length is 750 which means that your width is going to also be 750. So your maximum area, you're going to have A equals to 750 times 750. Your maximum area is going to be 562,500 square feet. For number 12, we're going to use the function here to determine the motion of a projectile. For letter A, we're going to find the distance when the projectile reaches to its maximum height. So we want to use the x equals to negative b over 2a. The b value is 1, and the a value is going to be negative 32 over 10,000. If you solve for it, this is going to equal to 156.25. For letter B, let's find the maximum height. So let's go ahead and use the function, insert the 156.25 that we found in letter A, insert the value into all the x's. So this is 32 times 156.25 squared over 10,000 plus 156.25. This whole fraction is going to give you negative 78.125. If you add to positive 156.25, this is going to equal to 78.125. And that's your maximum height. So what is the distance when the projectile lands? And understand that when the projectile lands, the height equals to 0. So 0 equals to the function negative 32 x squared over 10,000 plus x. If you factor out the x, you're going to get negative 32 over 10,000 x plus 1. Set each factor equals to 0. X equals to 0 or negative 32 over 10,000 x plus 1 equals to 0. And another x is going to equal to 312.5.
X equals to 0 is when the projectile is starting to shoot.
So the other x value, 312.5, this is when the projectile lands on the ground. So this is the one we want. X equals to 312.5. So what is the distance when the projectile is 50 feet high? So you want to say that height is 50 feet. This is equal to negative 32x squared over 10,000 plus x. Subtract 50 on both sides. Now you have one side equals to 0. And now we have a standard form of quadratic expression. If you put in a quadratic formula and solve for x, you guys are going to find out that there are two distances when the projectile is 50 feet high. The distances are 62.5 and 250. All right, that's it. Take care. Good luck with your homework.